Hello and welcome to this webinar on Composite Builds with Gradle. I'm Trisha G. I work for JetBrains. I'm the JetBrains developer advocate, mostly for IntelliJ IDEA, and I'm joined by Stefan Irmer from Gradle.
Hey, Trisha.
Hey, how are you doing?
I'm good, thanks. How are you?
I'm doing okay, yeah, I'm surviving. So our plan for this webinar is Stefan will go through sort of what composite builds are, the purpose of them, and give a demo. And then after that, I'll give a demo of how this looks in IntelliJ IDEA 2017.1. For our listeners, there is an area in GoToWebinar where you can ask questions. So you can ask questions as we go along. I will try and field them, and then I'll read them out, and then perhaps we can have some answers on the air as we go. So we'll try and find appropriate places for it, and there will probably be a chance at the end to follow up on any of the questions which haven't been answered so far. So without further ado, let's dive straight in. Over to you.
Awesome. Thanks, Trish. So at Gradle, we're all about developer productivity. And it turns out that this is not just about making the build system itself fast. There are a lot of processes during development that can significantly slow developers down. And one of those processes that we've looked at is when you try to combine projects and try to work on other people's code. For instance, when you need to fix a bug. So let's say you have an application that uses a library that's developed by a different team. And now you want to fix a bug in that library, or at least debug it somehow. What do you normally do? Well, you check out that code, you build it, you install it into your local repo, you change your build to use whatever snapshot you just installed into your local repo, and then you can finally use it, which is a pretty annoying slow workaround. And then for every little change that you try to do for that library, you have to install it again and then try it out in your code. So the repository structure really dictates developer experience, and this pain has led a lot of people to move more towards big monolithic repositories because it's just more convenient. You can work with all your projects at once. When really, in many cases, you would like to work on small repositories for modularity's sake, for performance sake, just keeping your build small, and also for code quality's sake. So there was really, up until now, this problem that you had to make your choice, basically. Either you separated your projects into different repositories, and you used external dependencies. So like as shown here in the dependencies compile, org, my company, and so on, which is deployed somewhere to your Artifactory or Nexus repository. And then you have this problem that I just outlined. If you want to make a local change, you have to install it first and then change your build to use that installed version. Versus if you put everything into one project, you can use project dependencies, which gives you a fast workaround, but it also tends to give you a large project that grows out of control pretty quickly. So this is what we try to fix with composite builds. So a composite build is very simply a combination of Gradle builds. You can include builds into other builds. Builds that are normally independent of each other, so developed by different teams. And the binary dependencies from one project to another are replaced with direct project dependencies. So this composite behaves as if you had one big build containing all the projects, so as if you had that Mono-Repo. And this allows you to do quick local experimentation. It allows you to import several builds together in the IDE, something that Trish will show later, and for instance do cross-repository refactoring if that's what you need. It allows you to smoothly migrate from a monolith to a multi-repo, or maybe even the other way around, depending on what you need. And one of the coolest features for me personally as a plugin developer is that this also works for Gradle plugins. So you can substitute a plugin with a local version that you've just checked out. So without further ado, I'm going to show you what that means on the command line. And you'll probably wonder, hey, where's IntelliJ? Well, I don't want to spoil everything, so I'm just going to use a text editor here. So let me just show you a very simple example of what I just explained. We have an application which has dependencies on two libraries that I've written, number utils and string utils. And when I go into that application, I'll actually find that I can't even build it because those libraries are not on JCenter, which I've listed as a repository, and I also don't have them installed locally. So if I say, Gradle, please assemble this, it's going to fail and say, hey, I can't find those dependencies. So now I could go and go into the myutils project that I've also checked out, and I could install it into my local repository, and then I could change my main build to use that local repository. So I could write something like, let's use Maven local, and then I could change my dependency declarations to, let's say, 1.1 snapshot, and so on and so forth, which is pretty annoying. But what I can do instead is tell Gradle, hey, assemble this, and just imagine that this other build at myutils is part of my build. So if I do that, you'll see that Gradle doesn't just build my app, but it also built myutils, and it built exactly the projects that I needed. And if I just say, Gradle, show me the dependencies for the compile configuration, then you'll see it says, I replaced number-utils 1.0 with the project myutils number-utils. So this just behaves as if I had included number-utils into my app. So this is really useful for quick local experimentation. And actually, this build has a bug. So let's say Gradle run, and you'll see it says, oh, 19 plus 23 equals 437. Unlikely. So let's look what happened here in our numbers class. Oh yeah, I made a simple mistake. Let's fix that and tell Gradle to build again. And you can see immediately number utils and only number utils is built again, and my app behaves correctly. So this is, in a nutshell, what composites are all about. You can build your main application and include other builds to substitute dependencies. So now you might not want to write this -- include build every time. You might want to make that a little more persistent. You can do that in settings.gradle. So for instance, you could just write include build myutils, but that might not be the greatest idea because my app is supposed to be a self-contained project. So if you check that into your repository, then your CI builds will probably start failing, saying, well, I can't find myutils. It's not at .. /myutils. But luckily, settings.gradle is just a normal Gradle file, so you can write a little bit of Groovy code and say, hey, if myutils exists, then include it. So you can basically create a dynamic composite that just reacts to the local developer environment that says, if you've checked out both of them, then I'm going to compile against that. You can also opt to not change your app at all and instead have a third project that includes both of them. So this composite project that I've created here is really just there to include both my app and myutils. And the result would be the same. So I could go there and say, Gradle run, without having to specify any included builds because they're persisted in the settings file. And you see it builds both myutils and my app and prints the right result. So this allows you to combine builds really flexibly, as we'll see in the more elaborate examples.
Just a quick point. Is it
Yes,
possible to increase the size of your command line a little bit?
I'm sure it is. Is that better?
I think it's better. I'll find out if there's any more queries on it, but it looks better to me.
Okay,
Thanks.
cool. So I said before that this also works for plugin development. So I like to develop Gradle plugins. So do many of you, I guess. So let's look at that. I go into the plugin dev project and into the consumer project. So I'm going to look at the project that's using my plugin. And I've actually added it as an included build here. So this is typically what you do when you develop a plugin, and in the same repository, you have a few examples that your users can look at to figure out how to use your plugin. And traditionally, what you had to do was install the plugin into a local repository and then try out the examples. Now you can just use Composite Builds. So in my consumer project, I say Gradle greet, because this is about a greeting plugin. And it says, hey, mate. And now if I go into my plugin and actually change some code and say, well, I don't like hey, I like hello, and say Gradle, greet again, I immediately see the effect. So I no longer have this annoying turnaround. I can just make changes to my plugin and immediately see what it does to the consuming project. So these are the most basic use cases. For a local developer to say, I need to experiment with another project. I need to experiment with a library that someone else has built and which has a bug, or I need to experiment with a plugin that somebody has built and it's not doing quite what I want. But composite builds are also useful for larger refactorings. So for instance, when you're moving from a mono-repo to a multi-repo, so currently all your projects are in one big repository and you'd like to split them apart, you have a bit of a problem on your hands, because if you just rip them apart and put them into different repositories, you're probably going to get into trouble, because what happens in a mono-repo usually is that modules reference each other in a very tangled way. There's lots of internal API usage. So if you just split them apart and give them different release cycles, what's probably going to happen is that your app projects are constantly going to be broken by seemingly innocent changes in the libraries, and then it turns out, oh, this internal API was actually used by one of the apps because they used to be in one big monolith where it was easy to fix up internal API usages. So ideally, you want to have a proper API before you split things apart. But enforcing this proper API split when everything is in one big build without any boundaries can be pretty hard. So what Composite Build allows you to do is to say, hey, I'm going to stay inside my monolithic repository, but I'm going to take my projects and already make them self-contained. So that's what I've done here. I've built a Mono-Repo app, and I've put a number utils and a string utils project into its modules folder. And these two projects are completely self-contained. So I could go into the Mono-Repo modules number utils, for instance, and say Gradle assemble. And this project builds by itself. So this is a completely self-sufficient Gradle project. I could import it into IntelliJ, for instance, and say, hey, I just want to work on number utils and nothing else, which will probably give me a faster IDE experience than importing my whole 500 module mono-repo. And I could also install it, for instance, into my local repository to use it later from another project. But I can also use them together. So what I've done here is I said in the Mono-Repo settings Gradle file, for every file in the modules folder that is a directory, include that as a build. So number utils and string utils in that case. And as you'll see, these dependencies that my Mono-Repo app has are binary dependencies. So they reference the binary versions of number utils and string utils. So when I say Gradle run, I get same bug. So we're going to fix that in a minute. And when I say Gradle, give me the dependencies of my Mono-Repo app, I can see the replacement that I expect. So let's just fix that bug again, this time here. And again, we see it's doing the right thing. And now I decide, okay, it's time to move number utils into its own repository. We've fixed everything up. We're ready to publish it as its own standalone project. And we're no longer going to bundle it into our big Mono-Repo. It's going to be the first thing that we move somewhere else. So let's move it somewhere else. Move number utils somewhere else. So now it'll no longer be found in the modules folder. And when I now say Gradle run, you'll see that Gradle is no longer building number utils because it didn't pick it up. And it's showing that bug again, because what it's using now is the version from my local repository that I installed earlier. So you can see string utils is still being replaced with the string utils project, whereas number utils is now coming from the local repo. And of course, you can imagine this exactly the other way around. If I have several repositories, but I'd actually like to work with a Mono-Repo instead, I could say, hey, it's quite a big refactoring to make it all a single multi-project build in one go. I don't really want to do that. I want to go more stepwise. So I'm just going to put all my builds that I want to eventually make subprojects and put them into a subfolder in my Mono-Repo and include them as included builds. And they will behave much like subprojects, just with a little more isolation. And then I can take them one by one and convert them to actual subprojects of my Mono-Repo. So the equivalent would be I move from somewhere else to modules, number utils, and then run. So that would be what I do if I was moving from multi-repo to Mono-Repo. So Gradle really makes these borders between Mono-Repo and multi-repo very fluent. One last thing that I'd like to add as a really cool use case that several big customers have already done is doing this on CI. So imagine you have your library team and your app team, and your app team is using library version 1.2. Now, they don't want to use snapshots because that's going to make their build non-reproducible, and they don't want to get any little bugs that the library team might be introducing in between releases. They only want to have something that's polished. But on the other hand, the library team would really like to know whether the app will still work with their next release. So there's a problem. There's two forces at work here. With Composite Builds, you can do that really easily. You just have a CI job that checks out both the library and the app next to each other and includes them both into a composite, and then just runs all the tests and says, hey, yeah, the app still works with the next minor release of the library. So the library team, instead of getting feedback 1 month down the road when the app team finally upgrades to their next release and says, oh yeah, you broke us, they get feedback the same day from the CI server saying, hey, by the way, your 1.3 upgrade is not binary compatible with 1.2. You've made a mistake here. Okay, so there are a few limitations right now that I want to point out. and which we're currently working on. The first one is that right now you cannot target tasks in included builds. So what that means is in my Mono-Repo app, I currently cannot say Gradle my utils build, for instance. This is something we'll fix very soon, actually. We also currently don't support custom publications. So right now, the substitution of project dependencies is completely based on project.name and project.group. If these match with the dependency notation, then it's replaced with a project dependency. If they don't, then not. We will expand this to work with the publishing plugins so that you can replace multiple different dependency notations with projects. Included builds also aren't currently executed in parallel. This is also in the works already, so that composite builds will be parallelized. Continuous build currently doesn't pick up changes in included builds. This is going to be fixed. It's not on the roadmap for the next month or so, but something we'll get around to for sure. We also currently don't support nested composites, so a composite that includes another composite build. But again, this is something that we'll definitely add. Something that's a little further out, if at all, is currently all builds need to use the same Gradle version. So the daemon that's used is the one of the composite root project. And all the included builds are run in the same Gradle daemon and using the same Gradle version as a result. So the last point was build scans. So you might know that Gradle has a cloud service called Build Scans that allows you to get deep insights into what's going on in your build, which tasks are taking along, etc. And they currently don't support composites, mostly because of how composites are wired up internally. So where we want to go there is to make them look exactly like a big multi-project build. So you can see, okay, this task came out of this build and it took this long, and it's one single task graph. So that's also in the works. Yeah, so please follow along on the Gradle blog if you want to know more about composite build development. We're going to invest a lot more into this feature in the next 3 months. And with that, I'll hand it over to you, Trish.
Okay, hopefully you can see my IntelliJ IDEA screen.
Yep.
Great. So I'm basically going to walk through the same examples that you walked through from the command line, and I'm going to show the support in IntelliJ IDEA for the same things. Probably the most complicated one is the first one that we're going to set up. This one doesn't have any sort of automation, so this shows the kind of worst case scenario where you have to set up everything manually. So here, this was the example that you had where you have a My app. Let's have a look at the main class. And this is your main class, which is dependent on these two things here. If we look at the build file, we can see these are the dependencies here. And what I wanted to do is I need to set up the composite build inside IntelliJ IDEA so that it picks up these dependencies and allows you to navigate to the source for these dependencies. So what we do is in our Gradle projects window, which you can open by doing, well, a number of different things. Either you can open it from down here, or you can open it from over here, or what I quite often do is I use Command E and I type Gradle, and then I can see my Gradle window is there. Let me close these down. So what I'm going to do is I'm going to add a new Gradle project to my project. This is going to be, let's make sure I go to the right place. I'm going to add build.gradle from the myutils project. Make sure that I've got the right version of Gradle and so forth. And then what I can do is I can set up the composite build configuration inside IntelliJ IDEA. So by right-clicking on the My App build, and I can select myutils as the project that I'm going to include in my composite builds. So Gradle is going to go away down here, rebuild the project. There we go. So these are the modules to include. I include those. And I need to, let's just open this up here. We can see this hasn't quite picked everything up, so I'm just going to refresh my Gradle projects. Whenever you're working in IntelliJ IDEA and you've made some changes to Gradle and the changes don't seem to have been picked up, the magic refresh button is the thing which will usually make everything work for you. So you can see down here we're doing a Gradle build. Okay, so hopefully what you can see is I pressed my magic refresh button here on Gradle projects, and now you can see that my app has the dependencies on the myutils modules as well, and my main class starts working. So if I run this from IntelliJ IDEA, then we should get an answer. Okay, interesting. Oh, I know what I've done. I'm not going to delegate the IDE build to Gradle for this particular instance because I want to show it using the IDE build, not Gradle. So when I run this, it will run it and give me an answer. Now, this is where we can see the navigation. So numbers.add, numbers is the thing that we imported from sample number utils. We go to add, and this is where we can fix this to be plus, for example. Let's see that what we did is when we navigated to numbers, we ended up inside the myutils project, and so we can edit this file directly. And then when we rerun, we should see the correct answer. So then we get the correct answer. And so now when we've got Composite Builds enabled in IntelliJ IDEA, when I'm inside my app, let's go back here. Oh, I'm already there. I can do things like, obviously I can navigate to the code, which is what we saw, but we can also do things like we can use the power of IntelliJ to do things like renaming things. And then when I rename that, then it's going to rename the method in my library code. Okay, so that was kind of the most difficult example because we had to manually add our dependency on different library code. What I'd like to show is I'd like to show you some of the sort of hopefully more straightforward examples of importing composite builds. So one of the things we can do, let's import a different project. So the composite one that was demoed earlier on from the command line, if I import this, then IntelliJ IDEA should pick up all of the dependencies that were part of the Gradle composite build. So when I open this up, it's picked up Java 9 automatically by default, which may give us some interesting results. I'm going to open up my Gradle window. So now in the Gradle window, it's still running some processes down in the bottom. So the windows will be updated when that's all finished. But you can see that I have a dependency on my app, I have a dependency on my utils, the number utils, and I have my root as well. So from the root, for example, here we go. So here's all the project data to import. Just accept the defaults that IntelliJ gives you, and then you can see all of the code for all of the different projects that we were dependent on. So when our composite build Gradle file had all of these included builds, IntelliJ found all of those builds and imported the code for those things as well. And then we can do things like in the root, for example, we can run the build from there. I really hope this works this time. Okay, so then everything worked. And when you run Gradle tasks from inside IntelliJ IDEA, you can either get it as a sort of familiar text output, or you can get it as a sort of pretty green blobs thing, so you can see exactly which things got ran and where any failures were, or if anything was perhaps ignored, for example. So that's IntelliJ IDEA's ability to look at all of these independent dependencies and pull in all the code for all the projects it's dependent on. let's have a look at another example. So if we look at, let's close this one down, import another one. So if we import our Mono-Repo, let's open up our Gradle window again. So again, we can see the individual projects that we're dependent on. We can see when this is finished indexing and so forth, we'll see all of this come up properly. And any minute now, we'll see these come in as IntelliJ modules. There we go. So these are the modules to import. It's picked them all up. And it's picked all of those up from these settings that we have from the build Gradle and from the settings Gradle. It's been able to pick up everything that's inside modules and import all of those as IntelliJ modules as well. So again, you get all the same things that you expect to be able to get. You can rename, you can navigate, and so forth. So from an IntelliJ user point of view, these composite builds just kind of create the IntelliJ project that you expect to be able to work with. So you can edit the file, rename stuff, and so forth. The final example that I've got was developing plugins. This one also should work automatically. I say the word should, but the first one should have worked as well. So if we open up our plugins,
I think the first one, the only thing that didn't work was actually running Gradle tasks. So it might just be missing the include build statement for the thing that you configured in the UI for running tasks.
Yes, I think so, but I was kind of surprised by that because I thought that was supposed to work automatically. So I'm going to go away and have a look at that and feed that back to our team as well.
Awesome.
So again, while it's still building and indexing and so forth, here we have our build.gradle, which has our build script, which is dependent upon this greeting plugin. Let's say OK to all of this. You'll see that IntelliJ actually brings in the code for the greeting plugin, even though what I did was I opened the project for the consumer, and it brought in the code for the greeting plugin. So if I run this, let's have a look at the consumer. What I'm going to do is I run greet Bob. So I get hello Bob. But if I wanted to change the greeting task to say hi, oops, with a capital, obviously, and get rid of this here, when I rerun, obviously IntelliJ IDEA is indexing everything because I've just created the new project. Let's try rerunning that. So I rerun and I get hi Bob. So again, like Stefan was saying, this gives you the ability to work directly with a project which is using a plugin, but also change the details of the plugin and see the effects of those changes straight away without having to rebuild whole things and upload them into repositories and so forth. You can just work with the code as if it's a single code base. I think that's pretty much all I wanted to demo. So perhaps we can have a look at any questions. Was there anything else that you wanted to cover?
No, that's pretty much it. It's really cool to see that. Maybe one thing to add is that, as you might know, Gradle maintains the Gradle Eclipse plugin called BuildShip, which also has this support since version 2.0 now. So what you just saw in IntelliJ, importing composites works there. What we don't have is the really sweet manual UI yet. So composing builds using the user interface instead of using settings.gradle. That's something that BuildShip does not yet offer.
So basically, whichever IDE you're using, you get the support for composite builds.
That's right.
Right, I'm going to have a quick look at the questions through here. Unfortunately, a whole bunch of them are, we just dropped the audio, so I have to have a quick wade through that. Let's have a look. So one of the questions was, does this work with a dependency in the build source project? Is that not the same as plugins, or no, that's the stuff that happens at the beginning before you...
Let me see. Oh, I see. So the answer is no, because build source is executed before the settings script is executed. So build source is quite special in that regard. So we can only tell what builds you have included after the settings script has been executed, and build source is executed before that.
Okay. Another question, does this work with configure on demand?
It should, yes.
Okay, it should. That sounds like, yes, demos should work. Here's a question about, it's about Java 9. I'm not sure if that's a good topic or not. How will Gradle Composite Builds work with Jigsaw modules in Java 9? Is there already a plan for supporting it?
It's not really related to Jigsaw modules, I think. So composite builds are really just a way to either break down a big build into smaller builds or combine builds to work on different ones in the same IDE session or in the same CI build. Jigsaw is much more on the Gradle project level, like on a single subproject. Defining API and implementation dependencies, defining API and implementation packages. So with Gradle 3.4, we already added the ability to split your API and implementation dependencies, and we will look into deeper Java 9 support this year. So we will add support for defining what your API packages are, and then either generating a module descriptor or maybe reading the information from the module descriptor. That's not entirely decided yet. But yeah, so it's rather unrelated to composites. We will work on it.
I have a whole bunch of questions around Java 9 and Gradle, but I think that's probably slightly off topic. Yeah. And probably more around my own personal pain points.
The general answer is Gradle currently doesn't run on Jigsaw because there have been changes over changes. Every time we tried and we thought, okay, now we run on Jigsaw, there was another nightly build of Jigsaw that broke us again. Mm-hmm. So we postponed that for a while to stop chasing this rabbit. But we will get back to it in April. Okay. To like the absolute minimum is running on Jigsaw, and then we'll see about the next steps. For instance, building modular apps and defining your API.
Okay. Yeah, I mean, I definitely experienced the fact that obviously Java 9 isn't out yet, so a lot of the early access builds were very much a sort of changing work in progress.
That's true. Yeah.
I have a question. How about including a second level dependency? I think you might have covered that in the limitations.
No. So it doesn't matter if it's a transitive dependency or a direct dependency. Any dependency can be replaced with a project from an included build. So this doesn't just work for first level dependencies that you explicitly edit in your build script. This works for any transitive dependency. And this even works like if you have in another included build a binary dependency that can be supplied by yet another included build that will also be replaced. So it's completely integrated into the dependency resolution engine.
Cool. So you can basically use it more or less where you expect to be able to use a dependency.
That's right.
And a related question, can I use this to replace jar dependencies from flat dir repositories?
Good question. In flat dir repositories, you usually don't have a group, so that might not work. I would have to try. Pretty sure we don't have a test case for that.
Right. I think this might be the same question as the second level dependency question, but it says my project A has a dependency on Spring, which has a dependency on Commons logging. Can I include Commons logging on as a composite dependency?
Yes, you can.
Yeah. Loads more questions about audio being off. Will the sound be captured in the webinar replay? No, I don't think so, because I lost sound as well and I'm recording the webinar. So what we will try and do is take a quick look at the video and see if perhaps we can edit it so that at least we don't have big gaps where we're losing sound. So we'll perhaps chop those out and stitch them back together. Any special requirements set up for Gradle wrapper?
That's not quite clear what the question is to me.
Okay, I don't have any more information. So if the person who wrote that question can perhaps add a bit more detail, that'd be really useful.
Yeah.
Okay. Still loads of things about missing sound. I'm going to have to sort this out, obviously. Have you enabled the composite build in Gradle project section? I think that was when I was doing my demo, and I think I showed that I enabled the composite builds. Oh yeah, and people suggesting I invalidate caches and restart. That was a very useful suggestion. If we wanted to be able to use delegate build run to Gradle, what would we need to do? Use settings.gradle include build.
Either should work. So I think what we saw in the demo was a bug in the run Gradle task when you use the composite configuration UI. That didn't work. I'm sure Trish, your team will fix that. And it already worked for builds defined with settings.gradle. So it should just transparently work.
It should, yes. The delegate build run to Gradle, all of the stuff should work for both, whether you're running it from Gradle inside the IDE, whether you're running the IDE build, or whether you're delegating the IDE build to the Gradle build. There, as you saw, there were some, what should we call them? Opportunities for improvement. And as I said, this is an early access, and this is kind of good news for us, because as we find these problems, it means that we can fix them before release. So all of this should work seamlessly in terms of whether you run it from Gradle, whether you run it from the IDE, whether you delegate the IDE build to Gradle. Is CLI support for Composite going to be included in near minor releases?
It's been there from the start since Gradle 3.1.
Can you run in debug mode and step into code that's in an included build? Absolutely. That's very much part of the point. So if you're debugging and you've got breakpoints inside an included project, then you should be able to stop at those breakpoints. So would build source work if you added the composite build in the build source settings.gradle?
Someone really wants to get build source to work. No, it's a valid point. Absolutely. It might. I haven't tried. To be quite honest, I haven't tried. It might fail. Give it a try and open a bug if it doesn't, please.
Do composite builds work for swapping out plugins with both the old apply syntax and the new plugin syntax, or only the new syntax?
Unfortunately, only with the old build script syntax at the moment, because the new plugin syntax is based on special publications, special so-called plugin markers, and composite builds do not yet support custom publications, which is why this feature is super high priority to fix in the next 3 months.
Is there a tool available to commit changes once, but commits get to their separate repos, i.e. string utils and number utils? So I believe the question here is in the project, let's see if we've got one open. I don't have one open, but let's say I make changes to the greeting plugin and I make changes to the consumer. If I do a commit inside IntelliJ IDEA, will that commit both those changes to the individual different repos? No, you have to commit each one individually to their own repos, I believe. I haven't tried that, but when I'm working with multi-repo projects, I usually manually make sure that I commit each set of changes to the correct repo. Will this work with configurations.all.resolution-strategy.failon-version conflict if a composite included in a library that collides with another dependency. I don't know what that means. Do you know what that means?
Okay, will this work with configurations? Okay, fail on version conflict if a composite included a library that collides with another dependency. No, because dependency substitutions are not based on a version. So a project dependency is only identified by its group and name. So it won't actually collide. It'll just be, the project dependency will just be used.
Okay. And all these should work with, oh, this is the Gradle wrapper clarification. All these should work with Gradle wrapper without any change to the build script, correct?
Yes, so, and I highly recommend everybody to use the Gradle wrapper in all their projects.
Yeah, I'm a massive fan of the Gradle wrapper. I don't have to worry about which version of Gradle I'm using. It just works.
Exactly.
Have you tried this with Git submodules? If yes, was it totally seamless?
Git submodules is certainly like very close to the modules folder that I showed in the Mono-Repo example. I personally don't have much experience with Git submodules, to be honest. But if you're using submodules, you know, without like leaving out Gradle, just if you're successfully using Git submodules in general, if that Git feature works well for you, then Composite Builds should work well. So you would just use a for loop, for instance, to iterate over your submodules folder and include those builds.
Great. That looks like all the questions that we've got. Hopefully we'll be able to write up the answers to those questions and perhaps include them in a blog post or keep them on the end of this video. As I said before, this video will be available probably in a few days' time, and it will be publicly available. Thank you so much, Stefan, for demoing Composite Builds.
It was my pleasure. Thank you.
And yeah, so thanks everybody, and goodbye.
See you.